Carbon capture and storage is considered essential for its contribution to climate stabilisation. Its success hinges on investment into scalable CCS technologies, clear regulations, and greater commitment by governments and private industry. Often flagged for being too expensive, in this episode we explore the latest advancements in CCS, efforts to scale its use, and discuss some of the projects that are underway. Welcome to Future Energy Insights, the podcast series that explores the future of sustainable innovation, brought to you by the World Future Energy Summit. My name is Rob Jones, partner at B2B Connect, and joining me for this episode is Siddharth Jain, Field Development Manager for Sharjah National Oil Company. Siddharth, you have two projects, or collaborations at least, at the moment they're ongoing, announced a couple of years ago. SLB is doing one, Sumitomo is the other. Where have you got to with those, and what are they trying to achieve in terms of carbon capture and storage? Because the interesting thing I think with these is they're not enhanced oil recovery projects.
Yes, Rob, that's correct. So let me start with the journey of SNOC on CCS and how our Sharjah National Oil Corporation began our thought that we want to be in this business. So SNOC is a national oil entity for the government of Sharjah. We've been operating for the past 40 years, assets for the past 40 years. And as an entity, as a government entity, we've been established for about 10 years now. So the fields that we're talking about, two of them are very mature. They have been, as I said, operating for 40 years. And they've come to the point in their field, or they came to the point in their field life where it was either abandon the fields or do something else with them. And as a group, we thought, what best can we do with these fields, and how can we add value to Sharjah and to the UAE? So we started this journey back in 2019. So it's been a while. We've been looking at it. So we went around, started looking at what can be done for mature fields. And the thing that popped up very easily is that we can store CO2 in them for the long term as a disposal, right? So we don't need to produce that CO2 back. It's a one-way street where we can take the emissions from around us and store it permanently in the ground for long term and be secure. I mean, the gas in these fields have been there for millions of years. So the CO2 that we inject in them, we can hopefully keep inside the fields for a very, very, very long time. So as part of this journey, we looked at the emissions around us. And what we found is that 35% of all the emissions in the UAE, CO2 emissions, are within 100 kilometers of us. Now, that was very encouraging. That took us to the next step of saying, okay, the pieces of the puzzle are there. We have the storage site. We have the emissions. So what else do we need to make this work? So that is where the collaborations that we've established a few years ago came about. So the one with Sumitomo is about how to get this into a commercial model. How can we commercially take CO2 from an emitter and get it to us, transport it to us, to our storage site, and store it. So it was looking at existing industries where CO2 does have a good concentration, where we can extract it at the least cost and store it permanently. The one with SLB is about how can we make a world-class storage site. So as SNOC, as Sharjah, what we bring to the table is the storage site that we have. So we wanted to make sure that what we present to somebody outside and how we evaluate that storage site is best in class. So with SLB, we looked at all the different aspects to make sure that we can store CO2 with confidence for the long term. And this is what we did. So it took us about 2 years with SLB to evaluate all the elements of subsurface, the geomechanical elements, the geophysical elements, and the actual volume that we can store in the ground.
And where have you reached in terms of, for both projects, where have you reached so far?
So in terms of the subsurface storage, I think we can confidently say that we have looked at all the aspects, and we can check all the boxes to confidently say, yes, we can store CO2 in the ground permanently. We can optimize few things, we can reduce certain risks, and that is where we are. So we've completed our collaboration with SLB. We're now into the next phase of evolution for the subsurface, where we're evaluating certain niche aspects to make sure that we can reduce the cost and get the cost to a point where we are very, very competitive. With regards to our collaboration with Sumitomo, so what we found is that retrofitting conventional CCS amine technology on an existing plant is very expensive. I mean, as a standalone project, it's sort of, and without any government support at the moment in the UAE, it is very hard to get into the voluntary carbon markets with as a standalone project of CCS. So we said we have to recalibrate and we have to look at things that are more innovative. So either look at new builds where CCS is combined, or is carbon capture is combined with a new plant from the very beginning, so that we can optimize the costs, share resources, and make more sense when it comes to a commercially attractive project, and a bankable project, of course. And so that's what we're looking. The other thing we're looking at with Sumitomo is innovative technologies such as DAC that can actually directly add value, which do not sort of rely on existing facilities, but find ways in which we can reduce the existing costs and get to a more competitive nature.
Okay, that's interesting. So do you think that you will be moving ahead with any sort of DAC projects? I know that there's been talk in the past, for instance, of using DAC in airports. Direct air capture,
yes,
obviously we're talking.
So DAC, or direct air capture, does have its direct benefits because we are actually physically taking CO2 from the atmosphere and storing it permanently. It's about the cost again. The cost of DAC is extremely high. I mean, it's an order of magnitude higher than what conventional CCS costs are at the moment. But so are the benefits, and so is the value of that carbon. So the value of the carbon that actually we can capture through DAC is quite high, and the buyers are willing to pay the premium that is required to get DAC off the ground. It is improving, like we have the improvements in solar PV. We see that the value in DAC, or the cost of DAC, is improving. There are integrations with actually using PV along with DAC to reduce the cost of DAC, but it will take a while. It's a journey, so we're not there yet, and certainly something that we have a close eye on, and we're collaborating so that we can see when to deploy it. And even if it is a pilot project, we're very interested to do this.
It's interesting that you talk about these technologies, because it feels like for CCS because there are reports say that if as nations, if as a world, we want to start to decarbonize, this is not possible without carbon capture and storage. So it's critical for countries, for governments, and for the world. At the same time, the technology is expensive, as you've said. So it feels like we are trying, companies such as yourselves are trying to get to the point where they can commercialize the technology, but find that commercial technology as well. And do you feel like you're heading towards that?
I certainly do think so. The world is maturing. The CCS industry is maturing. So again, CO2 capture and storage is not something new. I mean, the oil industry has been doing this for decades for the purpose of EOR. So the elements of the technology do exist. But again, deploying it on an industrial scale, on a global scale, for CCS to have a meaningful impact on on climate change, yes, definitely the technology needs to evolve to the next step to become more commercially attractive. Any estimate that you see about climate change, they do acknowledge that CCS is absolutely required for hard to abate sectors. There are very limited options for hard to abate sectors that they can do to be able to survive and reduce their carbon footprint. So CCS is definitely one of them, be it the IEA or any other metric. And certainly in the UAE as well, this is one of the ambitions that the UAE has to become or to be able to establish CCS projects into its energy portfolio, so that we can get to net zero targets that the UAE has set for itself. As a company, we are aligned. We have our own net zero ambitions. We have signed the oil and gas decarbonization initiative. So we do want to be able to provide that opportunity for everybody to decarbonize. And the storage site we have is actually quite massive. So we have the ability to store about 300 million tons of CO2, which can effectively help the UAE massively to decarbonize and reach its net zero 2050 objective very quickly. But commercially, let's talk about hard to abate industries. So as I said, there are limited options for hard to abate sectors such as steel, such as cement, because one, they're very carbon intensive to begin with, and they use CO2 as part of their processes as well. So both those elements mean that those industries have a lot of CO2 within their systems. For us to capture that CO2, we need to retrofit, or we need to have a carbon capture unit associated with one of those plants. these industries are mature. They have been existing for a long time. And the margins that they have are actually quite squeezed. They have optimized supply chains. They're very dependent on the commodity prices. So the final margins that such industries would have is actually to the very point that adding CCS on top of it would not work commercially. So they do need support from the government or from the regulators, or actually from the private companies, from the industry, to be able to take the leap forward to the next step.
I guess we're still in the point where we're trying to actually get to that next leap forward. So does SNOC have any sort of timeline on when you're hoping to be able to start begin commercially operating these projects, or these, I don't know, systems? I don't know what you would call it.
Yes, I mean we CCS is strategically a part of SNOC's ambition, or SNOC's strategy, and we do want to deploy CCS as quickly as possible. But then our existing fields also have some residual economic value. So we believe a timeline of about 5 years is what we're looking at, time horizon, where we can commercially extract the value from our existing resources, but at the same time the industry can mature to a point where we can deploy a full-scale commercial project and flip the switch and start injecting into the field as compared to producing from it. So a 5-year time horizon is something that we are looking at from our side. But
and 300, you said 300 million
tons. Yes.
How long do you think it would take to reach that 300 million tons? How much per year are you looking at?
I mean, to give you some perspective, the UAE captures about 0.8 million tons of CO2 per annum currently. So 300 million tons is a very long time for us to get to fill up the storage space. But certainly we see that commercial projects around 2 million tons would be a safer bet when it comes to optimizing costs, getting economies of scale. So that is the sweet spot that we would target. So around 2 million tons per annum, and 150 years to do so. But the field has the capability to go up to much higher volumes. And again, because there is the availability of CO2 emissions all around us within 100 kilometers, we feel that once the first project comes along, the subsequent projects will be much faster. So our ambition has sort of turned from creating a one project CCS to developing a hub for the Northern Emirates, where we can take a couple of sources and get them to us as a storage sink. And that would obviously help with the economies of scale to reduce the overall cost, not just for the emitters, but also for us as storage.
So effectively, what you're doing is now not just giving new life, giving a new economy. Effectively, you're turning a depleted field into a new revenue stream.
Absolutely. I mean, the depleted field is a revenue stream. I mean, even currently it's producing. It's a mature field. It is still producing. And we want to give it a new life because as a national asset, this is certainly something that field can do. It is a gas field that can store CO2 for the long term, and there is a demand, or there is an ambition for the UAE to store CO2. So as I said, the pieces of the puzzle are there. So it's about how do we fit them into a commercial model and how it is deployed. We're not there yet, but we are very close.